Yes, ma'am, it has started.
Shall do you? Yeah, thank you. Okay, so having looked at the logistics and I mean, anyway, it is there in the slide, so you can refer to it again. We'll go back to our technical part. So we, so in what we have done in the last class is we have looked at nested, I mean, examples where nested loops were required, and we used nested loops to print patterns, then print out the first k prime numbers, as well as the in the last part of the class we were looking at a particular question where, given an input integer n, we want to print out the prime factorization of that integer. And there are so we started with that question. I also gave you two ideas. Idea one, where say that you start with some number, assume that the number is not prime, and then try to first decide whether you start with I is equal to 2 to n minus 1, decide whether I is prime, and then keep finding the largest power of I which divides n, then print I and the corresponding power. Then we came to this idea 2, which we did not come to with any coding, but just by our thought process, that is it actually required to detect whether I is prime or not, and can we avoid that part, which will avoid some of the coding that is required. This can be done if we keep removing keep deleting or keep modifying the input integer such that we remove the prime number, or we divide it by the prime number, and we keep dividing it as long as it is divisible by that prime number. So this is the idea that we had stopped with, and I think you are going to code this up. So actually there is at least one student who has sent me a code. So Chinmay, are you there? And
Yes,
you
ma'am.
had
I did
sent me a
idea
code
one.
yesterday. Sorry?
I did idea one.
Yes, you did idea one. Are you comfortable sharing your code and explaining your code?
Okay, ma'am. I'll share my screen.
Sure. Okay. So, okay, what Chinmay did is that he has
Ma'am, I can't hear you or see you, ma'am.
yeah. So I think you should be able to share it now, Chinmay.
Ma'am, actually, there was a quite, we couldn't hear you for like 10 seconds.
Okay.
Yes, ma'am.
Okay, so you lost me, right? Okay, so I just said that Chinmay has sent. Chinmay is one of our classmates. He has shared a code with me which implements idea 1, not idea 2. And I think he said he's willing to share his code. So he's going to share his screen, and we are going to see how his code goes through. So are you there, Chinmay? Yes, I see that he's sharing the code. Okay. So maybe before you show us the code, you can show the execution for small inputs. So I also, yeah, one more small suggestion, Chinmay, is that maybe can you do Control C, and can you do GCC main.c, so that we get it into
Okay, ma'am.
compiling a program on our own. Sure. Okay. And if possible, increase the font of your this thing. Yeah, okay. This you can run it, finish it. Maybe for 100,
Okay.
can you just run your this thing program? Okay. So it does print out. So I think the first one is, of course, the prime number. The second one is the power. Is that right?
Yes, ma'am. Yes, ma'am.
Okay. Yeah, great. So can you just increase the font and show us and run us through your code?
Ma'am, is it bigger now, the font?
Yes, yes, it is better. Yeah.
Yes, ma'am. So basically, I first check if the number is composite. Only then I even start doing the process. If it's prime, the program just ends directly. And I defined its flag is just something I use to check whether it's prime or not. And so if it's composite, then I go into the loop and I get all the factors of it. I look at each factor and then I check whether each factor is prime or not. If the factor is prime, then I have this pow variable which keeps, which basically stores the power of the prime factor, which is initially 0, and then this enters the loop and it keeps checking, it keeps multiplying j with I and then keeps checking what the which is the largest power. Basically, once this loop terminates, you'll get the largest power of I, which divides n, if I is prime.
If I
And
is
then,
prime, okay. So first of all, I is a divisor of n here, right? You have already figured that I is a divisor of n. Is that right?
yes, ma'am. Yes, ma'am. I must be a
Okay, so
prime divisor for it to even
okay, so
enter
go down.
this.
Then you do okay on this line 41. Then you do not need that power is not equal to 0, right? Because power should be greater than 0. Then is that right? I mean, you can keep that check. I'm not saying, but if you know that I is a prime divisor of n, then power will be at least 1, right?
Oh, okay. Okay. I didn't put this. Basically, I first check if I is a divisor of n, and
Okay, so can you go
one
up
second.
in your code a little bit? Yeah, can you go to the beginning? Okay, further up. Yes. Okay, so I just want everybody to view the code. So there is n which he's scanning, which is okay. I is starting with 2, j is some j flag are local variables, and power is also something which is a variable which he will use. So this loop, which is while I less than n, is the main loop, or is that only checking whether I is prime or composite?
It's checking whether n is prime or composite.
Sorry, not n. I is not I. N is prime or composite. Okay.
Yes, ma'am.
So this is this loop, which is the which runs from 7 to 15, is the one which tests whether the input integer n is a prime or a composite number, and if flag is equal to 1, which means that it is a composite number, right?
Yes, ma'am.
Okay, so I think it would be very nice for you to comment your code, because it's a long piece of code, to say that at this stage you have understood that it is a composite number. Again, don't do it now, but I'm just telling for your this thing. And then you are reusing that flag. That is, you are saying that flag will be set to 0 and that will be again reused.
Yes, ma'am.
Again used for doing some other computation, right? And then you are trying to decide whether, again, from 2 to j is equal to 2 to I. So what is yeah,
Ma'am, so this is just checking whether I is prime or not. I'm
okay,
looking at
yeah, okay,
every
now
number between 1 and 2 and n minus 1, and I'm checking whether these numbers are prime or not. And then
okay,
I'm not, see, I'm not getting the divisors of n. I feel
yes,
like maybe I could have taken the divisors of n directly, but I'm finding numbers from 2 to n minus 1. I'm checking if
okay,
they're prime or not, and then I'm checking what powers of them divide n. So if I don't put
okay,
this check of power not being 0, then I'll get all the primes between 2 and n minus 1, whether or not they divide
okay,
this number or not, but comma 0. But I don't want that.
okay. Okay, sure. Okay, so I hope everybody sees the, at least the way Chinmay has thought about the code and written it out. I have not completely nailed down each of the pieces. I looked at it briefly yesterday, and then thank you, Chinmay, for trying it out. I am sure other people have also tried it out. If you send out to me, we will pick up different people to present code in the class from in future. Now, what I want you to observe is that this piece of code requires several things to be correctly done. One, that he has to check first whether the given number n is a prime or a composite. Then for each I, he has to check whether it is a prime or a composite, and then find out the power of I. And it becomes a piece of code which is which is a long piece of code. He has reused the flag again, which is fine, but it requires bookkeeping, which has to be done carefully. Now I'm sure others and maybe Chinmay also has tried out the simpler idea, which is idea 2, and we will show how the idea 2 leads to a much smaller piece of code which just fits in one slide, right? So thanks Chinmay for sharing your code, thanks
Okay,
for
ma'am.
trying out, and thanks to all those who have tried out this code as a homework exercise. So I'll again start sharing my screen. uh, okay. Okay, so now that we have seen this first idea being implemented, it was time for us to see the second idea being implemented. And as we already agreed in the last class itself, that idea 2 is simpler to code, but it requires thinking before coding. So I hope all of you got some time to think about how you can code it. And this is the, I mean, again, the part of the code which is include stdio, all those are omitted. But this is the heart of the code, that is you scan the input integer n, and from I is equal to 2 to n, you start looking for whether the integer I divides it. We are not even getting into testing whether I is a prime or not, but we are keeping a count of how many times does I divide n, if at all it does. So here is where is the nesting of the loop. So you have a for loop which is running from 2 to n, and then for every I you are checking whether I divides n. If it does, you are not only incrementing the count, but you are also modifying n. This is very important. N is equal to n divi. This was what we agreed. And at this stage, if at all I has divided, or if I at all I divides n, then this count is going to get modified to be something which is greater than 0, in which case you print that I is a prime number which is dividing n by for so many times, or this is the count by which, that is the power in the prime factorization of n for the prime number I. And since you have already modified n, you don't have to worry about whether some non-prime number, for example, if 4 divides that number, 4 will no longer start keep dividing n, because you have modified this n appropriately. So if you stare at this piece of code, you will see that it is much smaller, very succinct, and gets rid of the business of checking whether I is prime or not. So I hope many of you tried writing this code, and this exercise of, even if you don't succeed or don't get the exact same code or make some mistakes, trying it out before you see the correct code is something which will be extremely instructive for you throughout this course. Okay, any comments or questions on this code? Okay, so I see some people are typing some codes, but I'm not reading it. I think they are the idea 2 which is implemented by you, and you are printing it out. So yeah, thanks to all those who tried it. But yeah, and it seems to be the similar code that I'm flashing on the screen. Okay, so any questions? Sorry. Yeah, so this I didn't know whether we'll go over Chinmay's idea here. So if you haven't tried out, try coding it with idea 1, and the code will be long, cluttered in the sense it will have several portions. Of course, it can be simplified by using functions like is prime, because then the first part of Chinmay's code will go away. He will just call is prime, and then for every uh, time he's checking whether that integer I is prime or not, he's going to call that function. So this already tells us that we should have functions which will modularize parts of our code, and we'll come to functions very soon. So that those will help us declutter such pieces of code. But the point of this example is that you don't even need functions. You can simplify that piece of task by doing a little bit of thinking ahead of the coding that you start doing. Okay, so with this we will complete the discussion. Yeah, okay.
Hello, ma'am. Ma'am, here this n equal to n by I sentence is the one which allows us to avoid the composite factors, ma'am.
Which avoids us to?
No, which helps us to, which avoids the composite factors of n, no, ma'am. This is n equal to n by I.
Yes, because that is why, right? We are modifying n. That is the main thing that allows us to avoid the cumbersome part. Is that what you're saying?
Yes, ma'am. Composite factors, yeah.
Yes,
Okay.
yes. Yes, so the main thing, as I have written in the idea too, is that yes, this modify n is something which is very important. Is that we are allowed to modify n. If you require that n should be saved somewhere, that is also easy. You can save the n value somewhere earlier. That is not difficult. But that whatever you are going through is getting changed, and that is the one which is driving your outer for loop. That is changing in the inner while loop is something that you should observe. Similarly, a small but important thing is that this count variable should be initialized to something 0 inside the for loop and not outside this for loop, because every time you are trying this I, you want to make sure that the count is counting how many times I divides n and not have something which is from the previous iteration. So these are important things, that not only that I is yeah, so not only that n is getting modified, which is controlling this while loop, n is also controlling the outer for loop, and that is okay. So please spend time thinking about this small piece of code where this is the same n that is getting modified.
Ma'am, should it be I less than n or I less than or equal to n?
Okay, so
Because
yeah, good question. So should it be I less than or equal to n or I less than n?
Less than or equal to, or else prime numbers won't be printed.
Good. So for prime numbers, you want to go all the way up to n. So there is, that's what I, again, in idea 2, I have removed this part that assume n is not prime.
but suppose n isn't prime, right? And suppose it's 4, then it'll go into the loop. I will be 4. 4 is less than or equal to 4. Go into the loop. Count will be 0. Then while
Wait,
n
no,
percentage I equal to 0, then 4 will divide 4. So then
just go slow, right? That is why I made this point. So if n is equal to 4, let's run this program. So n is equal to 4, I starts with 2, and n mod I
oh,
is
n is
equal
getting
to 0.
modified. Okay, ma'am. Sorry, ma'am.
That is the point I made, and it's good that you have brought it up again, because when n is equal to 4, n is getting modified, n becomes 2 here, and therefore it won't even go into the loop once again for the outer for loop.
You're stuck. We can't hear you.
Hello, ma'am. We can't hear you.
Okay. Kaushal, am I audible?
Yes, ma'am. Now you're audible. Yeah.
Okay. Yeah, I think I lost you for a few seconds, right? Okay. So the more succinct the code it is, the more, the more attention that you have to pay. And writing this piece of code is not immediate for the first time. So I do really hope that you stare at this, try to write it, even after you have seen this, try to write it on your own and reproduce this piece of code so that it correctly prints out the prime factorization. Okay, so are there any other questions? Okay, so having said this, let's go to the next loop construct that we want to introduce in today's class, which is the do while loop construct. So we have already seen two loop constructs, one the for and the second the while loop construct. So this is again a different loop construct. The syntax is as follows. You do something, a set of statements while the expression is true. So the way this is going to get executed is you are going to execute the set of statements first, then evaluate the expression, and if it is true, you go to step 1, else you exit the loop. So unlike the for and the while loop, in which you may never enter the loop if the expression turns out to be false in the first place. In the do while loop, you are always going to enter into the expression, enter into the body of the for loop at least once, and execute those statements, assuming that there is no if that is getting, if expression which is getting evaluated false, but assuming there are some statement, in fact, that if is at least going to get executed. So this is how the do while loop is. We have the syntax for the do while loop. Again, why do we have several loop constructs? They are natural for different scenarios that we want to code up. We have already seen examples of this, but just to exercise this loop construct, we are going to go back to our favorite GCD example and look at Euclid's method first. That is the same thing that we are very familiar with now. And the critical part of the code is this, that is, we are assuming that we have two positive integers x and y, and we are going to run this loop as long as x mod y is not equal to 0. When we exit this loop, x mod y is equal to 0, which means that y divides x, and therefore in y we have the GCD of x and y. And again, like in the previous example, x does get modified, and we have seen, we understand this code. So I want you to stare at this translation of this while, the while construct that we have used to the do while construct that I have translated it to. Please stare at this piece of code and then tell me whether it behaves the way we want it to behave, and does it compute the GCD of x and y. So please write down the answers in the chat message and I'll look at them. So stare at this piece of code. Okay, so a small important thing is that in the do while construct, we have the expression and then we have the semicolon at the end of this. This is the way the syntax of this construct is. Okay, so I see that some of you have started answering. I request others to also work out this piece of code for small examples and try out whether this indeed goes through and we get the Okay, so you have observed that many of you have observed that this fails when y is already dividing x. What happens if y is not dividing x? Let's say that let's say we have numbers like 5 and 3. So what happens for that? The GCD is 1. What happens if the input is 5 and 3? So it goes into this, then 5 is equal to 5 mod 3. What is the next? Sorry?
I'll type.
At
No,
some
you were
point,
saying.
oh sorry.
Yes,
At
Sri
some
Lakshmi.
point,
Yeah.
y will end up becoming 0. Then x mod y would be not
So
defined.
let's execute it for 5 and 3. So if x is equal to 5 and y is equal to 3, x is equal to x mod y. What is the value of x after this update? 2.
Yes,
Is
ma'am.
that okay? Yeah, and then you are going to swap. So therefore x becomes 3 and y becomes 2, and you x mod y is not equal to 0, you still enter the loop, and therefore x is equal to x mod y, then x becomes 1, and then because of the swap you will have 2 and 1, and then you will have while x mod y is not equal to 0, and then you will get 1. So therefore for 5 and 3 it does work. However, for things where you already have so you have that y is a divisor of x, you will see that you will already update x, and therefore at this stage when you do this swap, you can have actually y is equal to 0 and you are doing division by 0, right? So that is something that can cause an error, which most of you have, or many of you have observed here. So what I would like you to do is modify this without changing anything inside this, inside in this do while part, but change something in the expression and possibly something else which will allow you to keep this piece of code, but output the GCD of x and y.
I must change where, ma'am? Which expression you change?
So that's what I'm saying. You can change anywhere except you are not allowed to change this do up to this part, right? Whatever I have highlighted, x is equal to x mod y, and the swap of the x and y, that is not something that you are allowed to change. But you are allowed to change things outside this part, which is non-blue, right? And you should output the GCD of x and y. Of course, do not write a new while loop below that. That is not the intent of the question. Okay, so that is why I said you do not change anything in the while loop, in the body of the do while loop, change something outside the body. So, okay, so there are things that people are suggesting that do not go into the body of the loop when it is y divides x. But I think there is a cleaner way to do the change in the in the expressions. So we let the body of the while loop be exactly the same. Body of the do while loop be exactly the same as the body of the while loop, which is x is equal to x mod y, and the swap that is doing the change between x and y. However, we terminate, so we write the expression as while y not equal to 0. And if you say that while y not equal to 0, if that is your termination condition, you will terminate when y becomes 0, and therefore you cannot output your y as the GCD, because your GCD is not y. In fact, your GCD will now reside in the variable x, which is going to contain the GCD. So what we have done as our change is that we are going to instead of running our loop, so for example, for the 5 and 3 case where we had stopped at 2 and 1, we will go further and we will change it to 1 and 0, where x becomes 1 and y becomes 0, and then we will output x instead of outputting y, which is the change. So in fact, this is also leading us to the recursive definition of GCD, where GCD of GCD of anything and 0 is the other number, assuming that the other number is not 0. And then if both of them are non-zero, then we already know what to do with the GCD. So when we come to functions and recursive functions, we will use this definition and implement a recursive function. But at the moment, we are making use of the do while construct to modify our earlier program by keeping the body of the while loop exactly the same as we had earlier, but changing the expression as well as changing the variable in which the GCD resides. It is no longer in Y, it is in fact in X now. The other thing that I want you to observe is when we wrote the while loop earlier, we had assumed that y is greater than x and we had greater than or equal to x, and we had also assumed that the two values x and y are positive integers. So none of them are zero. So you can safely do this x mod y because you will not get the division by zero. On the other hand, even after those assumptions that we have in the for the do while loop, because you are executing at least one iteration of the do while loop, which is modifying x, you and swapping x and y, it doesn't imply that at this stage y is greater than 0. Therefore, when you did division by y, it could have led to an incorrect thing, that is, in fact, you are dividing by 0. So this is something that has changed when you have changed it from the while construct to the do while construct. Again, this is not the only way, but this is one of the way to modify this program to use the do while loop. And note that the change is significant in terms of the way the variable that contains the GCD itself has changed. Yeah. So any other questions?
Hello.
Yes.
Do while loop takes a semicolon after its statement, isn't it?
Yes.
While the other loops does not.
Yes.
Okay.
Sorry. Yeah, so I just will highlight the syntax. So this is do. There is this statements that are put in these braces. If there's a single statement, you can avoid the brackets. Then there is a while, and then there is an expression that you can have. It can be while one or something. Then the coming out of the loop is in your in the control of the body of the for loop. And then there is this semicolon which is required. So you could have done, I mean, in the while loop also you could have said while expression semicolon, but that means that there is an empty while loop. In fact, this semicolon is something which is required and says that this is the do while loop that you are executing. So is that clear, Gitar Thare? Yeah.
Yes, ma'am.
Okay. Yeah. Okay, so let's move ahead. I just want to make these remarks. Actually, one of them was what Gitartha said, that you have this semicolon which should be at the end of this expression, which should not be in the case of while loop. Otherwise, your body is empty. And in the do while form of this loop, you will enter the loop at least once. This is not the case for the for and the loop while constructs. And typically the do while loop is used or is natural when the expression does not have to be tested for the first time. You assume that the expression is going to be true for the first time, and you only after the execution of the first set of statements in the body, it may get modified and may turn to be false. Then is where you want to check it. So there are conditions when you start with some, I mean, you want to find the, you want to take in input and then process it the way we had done that menu based program calculator, where you may not want that the first time user is going to press a quit, in which case you will have a do while loop. And some people had suggested also at that time. Okay, so I think I am almost done with the time, but I just have this small thing that I would like you to think about. This is the same staircase that we have been using, but it was a staircase of stars. It instead of having a staircase of stars, we are having a staircase of numbers. What is the expected input for expected behavior of the program? It accepts an input integer n, which is greater than or equal to 1. So at least once we have to print something. Print this staircase of n rows. So if n is 4 here, you have to print 4 rows. Row 1 has a single 1, row 2 has 2 2s, row 3 has 3 3s. Actually, sorry, so there is a small error in the this thing. It should have 3 3s and then 4 4 fours. I'm sorry about this. So yeah, so it should have 1, 2, 3 and 4 columns respectively, and row n has n times the number n. So this is what you want to print. Use a do while loop to do this, and from our yesterday's class it will be clear that you will require a nested do while loop. So use the do while loop in a nested form just to exercise the nested do while loop, and print out the staircase. So I'll stop here because we are running out of time. I'll stop the class. There is this program is there in the slides. I won't show it to you now, but when I upload the slides, it will be available for you. Okay, so I am going to stop the recording. If there are questions, I'll be here for a few minutes.